Human skeleton. The framework of body is made up of 206 bones, associated cartilage, and joint that form the human skeleton. It's easy to think of bone as a relatively lifeless tissue, but that's not the case. The skeleton is a living organ system that can grow, repair, and remodel. Skeletal function. The skeletal system serves many roles that we require for optimum health, movement, and protection. The skeletal system has 5 primary functions. First, movement. Bones come together to form joints that allow motion. Structural support. The skeleton provides the structure and support we need for movement. This is one factor that separates human from amoeba or jellyfish. Protection. Our essential organs, such as the brain, spinal cord, heart, lungs, are protected by the skeleton. Calcium storehouse. Calcium and other minerals are stored within bone. Blood cell protection. Marrow within bone produce blood. Importantly, these 5 functions compete with one another. For example, movement is best accomplished with lighter skeleton. However, for bone to be strong, they must be also relatively heavy. If calcium is taken out of bone to provide nutrition to the nervous system or muscles, bone can become weaker and reduce the protective role the skeleton must play. Nevertheless, the bone that form the skeletal system can adapt to those competing demands. About the skeletal structure. The bone that make up the human framework can be divided into axial skeleton and appendicular skeleton. The axial skeleton is composed of 80 bones, form the skull, vertebral column, rib cage, sternum, and sacrum. The remaining 126 bones of the upper and lower extremity form the appendicular skeleton. The size and shape of a human bone can vary greatly, depending on role they play. The largest bone in the body is the femur, and it's approximately 18.9 inches long, and in diameter it's around 1 millimeter. The smallest bone is the stapes, located within the ear. Based on their shape, bones are classified as long, flat, short, or regular, or sesamoid bone. The vertebral column, sometimes referred to the spinal column, is a special important structure within the skeletal system. It consists of 5 regions. If we picture it from the base of your skull down to the tailbone, the cervical region is made up of 7 vertebrae, the thoracic region is 12 vertebrae, and the lumbar region is 5. Sacrum consists of 5, and the coccyx has 4. However, these vertebrae are fused together and don't move. That means the vertebral column is composed of 33 vertebrae, but only 24 can move independently, ranging from the first cervical vertebrae down to the last lumbar vertebrae. Movement between vertebrae is made possible by facet joints, which are spaced between the bony protrusions of 2 adjacent vertebrae. Bone structure. If you are ever held a human bone in your hand in anatomy class, you might think that the bones are generally light, brittle, and easy to break. However, bones within a living human are heavier, stronger, and more durable. That's because living bones are full of vessels, nutrients, and that make them adapted organs capable of growth, repair, and remodeling. In this section, we will cover each of these functions. Growth. All bone in the form of cartilage before birth, after person is born, and throughout development, the softer cartilage is slowly replaced by harder bone throughout process called ossification. Therefore, because adolescents have softer bone, it's more difficult for a 4-year-old to break bone than it is for adults. This hardening process continues until person reach full development between 18 to 25 years. Bones not only get harder during development, they also grow longer. The length of bone increases at the epiphyseal plate, where cartilage cells divide and push the newly formed bone cell toward the shaft of the bone. Eventually, the cartilage cells become mature bone cells to increase the bone length. After a person reaches adulthood, the epiphyseal plate close and form an epiphyseal line. At this point, it is not possible for the long bone to grow longer. Each long bone within the appendicular skeleton has an epiphyseal line at each end. Second function of the bone is repair. Bone can repair various types of damage. Whatever the damage is from severe break like macro damage or mild tear within a bone matrix that can be felt, which is micro damage. When a bone breaks into two or more pieces, the painful macro damage often require a medical intervention with cast or screw that allow the bone to heal back to its original form. The healing process takes anywhere from 1 to 3 months, depending on the location of the break and the amount of blood supply it receives. In many cases, a broken bone can heal stronger than it was before the break because of the body will produce extra bone at the site of damage. Micro damage results from microscopic tears within the bone matrix. It occurs as a normal daily process during activities such as walking, running, or lifting weights. All bone is replaced every few years from accumulation of the micro damage and repair process. Normally, micro damage is not felt. However, when people just increase their activity level to the point where the balance between micro damage and repair cannot be maintained, stress fracture can occur. Because most stress fracture cannot be seen within the normal X-ray, CT scan is usually required to confirm diagnosis. The third function of the bone is remodeling. When a bone changes shape, it's known as a remodeling. Bone can grow or shrink depending on the stress or lack of stress that's placed on it. For example, when a person lifts relatively heavy weights, the body responds by laying down extra bone to thicken the diameter in a process called deposition. On the other hand, if the person is bedridden or paralyzed, the body can decrease the bone diameter through resorption. This theory of bone adaptation is known as Wolff's law. Train your brain. Can a poor diet weaken your bone? Absolutely. Bone are living tissue that require nutrients for growth and maintenance. Therefore, a diet that's deficient in protein, vitamin C, calcium, or vitamin D can all weaken the bone and potentially leads to disease. Rickets is a bone disease that occurs from a vitamin D deficiency. Okay, bone relay on 3 cells type during remodeling. After bone is damaged, osteoclasts show up the impaired bone tissue, which is called resorption. Importantly, osteoclasts are also responsible for the loss of bone when a person is inactive due to injury or disease. Next, if there is stimulus for growth, osteoblasts come into play and lay down new cells, new bone. Finally, this osteoblast transform into osteocyte or mature bone cell. Importantly, bone remodeling occurs throughout the life. When a person is younger, remodeling happens at a faster rate. A person grows older, the remodeling process typically slow but continue nonetheless. Bone structure. Bones are rich with blood vessels, cells, and nerves that allow it to perform the function we just covered. The periosteum and the endosteum are connective tissue that cover long bone and they contain the cells responsible for growth, repair, and remodeling. The periosteum covers the outside of the bone while the endosteum covers the inner lining of the bone and the medullary cavity. Before we discuss papilla and nerves, let's go over 2 primary types of bone tissue. The structure of bone is not uniformly hard material as it might seem if you held in your hands. Indeed, bone consists of 2 different materials. The outer layer, compact bone, and the inner protection of spongy bone. The compact bone or cortical bone, this hard outer layer of dense tissue is strong, solid, and resistant to bending. Approximately 80% of a person's skeletal mass comes from compact bone. The spongy bone is light, porous inner bone material that forms the layers of bone structure called trabeculae. Osteoporosis mainly affects spongy bone. The combination of compact and spongy material is what gives the bone its strength, while still being entirely of compact material that would be too heavy for efficient movement, and spongy bone alone would not give bone the strength they need.